So I will check with Dr. Udesh what to do. Okay. So have you followed Dr. Udesh lecture? You said that there is a problem. No, you can't. So you can't go through that lectures also. No, you can't open or something. ඒක ඔක්කොටම තියෙනවද මේ ප්‍රශ්නේ අර ડોક્ટર උදේශ්ගේ මොන හරි ලෙක්චර්ස් වලට යන්න බෑ කියපේ? hello අර ડોક્ટર උදේශ්ගේ මේවට යන්න බෑ කියපේ ඔක්කොටම තියෙනවද මේ ප්‍රශ්නේ තාම?
මම කලින් චෙක් කරලා යන්න නම් බැරි වුණා.
Wait, I talk. Actually, this Monday I talked with Dr. Udesh. He said that he will fix it. Let's see. This is your LMS page, no? So you can open, no? The problem is that you can't download. Is that the problem? No. So we can go to the lectures, no?
The problem is we can't download.
Okay. So anyway, you can go to the lectures, no?
Yes.
Yeah, I think this is private. No, it is not in public domain. Okay. So actually, I asked Dr. Udesh about this issue. It is still private. Not. So once we upload the video, I don't know whether we can, when we are uploading, we can select private or public. Okay. So once we select public, I don't know whether we can do it or not, correct it or not. Anyway, I will inform it again. Okay. Okay, so we will start our session. Okay. So I think now we are familiar with the sampling. Okay. I think actually these things are related with discrete time signal, the properties of discrete time signals. Okay. So there are some basic properties of discrete time signal, especially sinusoidal signal. With sinusoidal signals, okay. So maybe we no need to much focus in on these things very much, okay. Maybe this relationship sometime may be useful, okay. This one, omega k is equal to omega naught plus 2k5, okay. So I will explain it later, okay. What is this, okay. And we have seen the step of analog to digital conversion. Okay. Actually, we are in the first step, that is sampling the analog signal. Okay. Now I think you have the idea what is sampling. Okay. Sampling means we are collecting the voltage samples of the signal. Okay. So we are talking about voltage signal, most probably. Okay. The time, the voltage is changing with the time. So it is a voltage signal. Okay. So you can get the voltage sample uh, with a certain period. That period is called the sampling time. Okay, that period is called the sampling time. This or sampling period, sampling time or sampling period. Okay, so uh, and okay, so that's time is called the sampling period. We have already discussed those things. Okay, and uh, the sampling rate, that is the number of sample per second. Sampling period is one sample, was the time taken to get one sample, and sample rate is number of sample per second. It is given by 1 over t. If the sampling rate, sampling period or the sampling time is t, the sampling frequency is given by 1 over t. Okay, so it is also we have learned. Okay, and uh, so once we sample the signal, once we sample the signal, give me a moment. Okay, once we sample the signal, so we have already discussed those things. Okay, so normally uh, continuous time signal, we normally represent like this with respect to t. So it is a function of t. Okay, so once we get the sampled, once we get sampled, so it is a sampled signal. Okay, so the sampling can be done using a switch. Okay, if you are sending the signal using a switch, you can get some samples. Okay, so samples may be like this. Okay, and not you are not using the time to draw, not to normally represent this discrete. So this is the discrete, so this is a continuous time signal. Once you sample, it is a discrete time signal. Okay, this is a continuous time signal. Once you sample it, it will be a discrete time signal. The time will be discrete. uh, the time will be a discrete variable. Okay, so uh, so you are not using this time. Instead of time, you are using n. That is the sample number. That is the sample number. Okay, so you are normally representing a discrete time signal using sample number. So it is a function of n. It is a function of sample number. So it will be xn. Okay, and there is a corresponding time for this sample number. Okay, for example, zero sample is at 0 second. First sample is at ts second. That is a sampling time. The second sample is at 2s second. That is ts is the sampling time. Likewise. Okay, so the end sample is at nt second. So t is equal to 1 over fs using this, and t also can be equal to n over fs. Okay, so this is also, you have already know that this is also we have identified very well. Okay, so this is the sampling process. Okay, and actually this sampling is done in a certain time period. Okay, uniform time period, we called it uniform sampling. And to sample the signal, this is not a pulse. Okay, this is not a pulse, it is an impulse, because there is no time gap. Okay, for this pulse. Okay, the time gap is 0, time duration is 0. So this is an impulse. Okay, so this is called impulse sampling. Actually, in practically, the impulse sampling is not possible because we can't generate impulse. We can generate only pulse. Okay, like this. I think we have discussed these things, all these things. Okay, so in practically we can generate this kind of pulse. Okay, so it has amplitude and it has a duration, pulse duration. It has a pulse duration. Okay, time. Okay, but impulse has amplitude. It doesn't have a pulse duration. The duration is 0. Okay, so you can't generate pulses with 0 pulse duration. Okay, so practically you can't generate impulse. Okay, so this is called impulse sampling. We are talking about actually impulse sampling. Okay, impulse sampling. And uh, also we called it ideal sampling. Okay, ideal sampling, because this is ideal sampling. Practically we can't do this, can't achieve this. Okay. Mhm. Okay. Now, so if you are given a signal, if you are given a sinusoidal signal like this, okay, if you are given a sinusoidal signal like this, xt is equal to a cos 2 5 ft plus 5, this kind of signal. Okay, this is a sinusoidal signal, is standard sinusoidal signal. And once you sample it, that means if you are sending it through a switch and you get the sample, okay, the sampled signal will be a function of n, not function of t. So it is a function of n, xn. Okay, and so once we sample in xn, we have only samples. Okay, we have only samples, some samples. Okay, so you can replace this t with the sample time. Okay, the corresponding sample time, that means using this. Okay, instead of this t, you can apply cos 2 5. So it use capital F to represent the continuous time signal, continuous time frequency, capital F, F cos 2 5 capital F. Then instead of t, you have to put the corresponding sampling time, because here we have only samples. Okay, not a continuous value, samples value. Okay, so you can replace like this, nt instead of this t. So here actually we have the t. Instead of t, we can substitute nt. Okay, using this identity. Okay, using this identity. Okay, so so you can see that now xn, so the phi is there. Okay, the phase shift will be there, it is not changing. Okay, so you have a cos 2 5 nt. T is equal to 1 over fs, 1 over sampling frequency. So you can write this as f over fs n plus 5. Okay, so now you can see that this is a function of n. Okay, the n, this is xn. This signal is a function of n, not time. But there is a corresponding time value. So okay, don't forget it. The corresponding time value you can get using nt. That is the corresponding sampling time. Okay. Okay. So this is the discrete signal. Mathematical representation of the discrete signal. What you have to do is, instead of this t, you can apply nt. Then nt, t can be written as 1 over fs. Then you can write like this, right? Like this. Okay. So now this will be the discrete time frequency. This is the discrete time frequency. This will be the discrete time frequency. Okay. And it is normalized by the sampling frequency. Okay. So this is also called as normalized frequency. Normalized frequency. Actually, this is a normalized frequency. Okay. When you are changing the sampling frequency, the discrete signal frequency also will be changed. Okay. Okay. When you are changing the sampling frequency, the discrete signal frequency will be changed. That is why it is called as normalized frequency. Okay. So that is the frequency of a discrete time signal. Okay. So this is the normalized frequency. Okay. Okay. And this is using the angular velocity. This omega is the normalized angular velocity. And this capital omega is a continuous time signal angular velocity, angular frequency, omega, 2πf. Omega is equal to 2πf, you know. Okay. So the omega is equal to 5f. So what you have to do is, okay. So you can multiply this side by 2f and this side by 2f. So this will be simple omega, and 2π capital F will be capital omega. Instead of 1 over fs, you have put t here. Okay. So the same equation. Okay. The same equation is there. No any difference. Okay. Omega is equal to 2πf. Okay. And t is equal to 1 over fs. Okay. Using this two identity, this equation is derived. Okay. So it is very clear. Okay. Now, so here, this one is a very good, very interesting property. Okay. So this capital F is the continuous time signal frequency. This is the continuous time signal frequency. Okay. Now you can see that this capital F can have any value. It can be minus infinity to plus infinity. Actually, in practically, there is no signal called minus frequency signal. Okay. There is no practical signal called minus frequency. Okay. But once you put as well as complex frequencies and minus frequencies are not available practically. Okay. There is no any meaning of that. Okay. Minus frequency. Okay. So oscillator only generate the frequency that is a plus value. Okay. There are no oscillators that is generating minus value. Okay. But here the minus infinity you can put, because mathematically this is okay. Mathematically it is okay, and it will lead to a phase shift actually. Okay. For example, if you send sine minus 30t, this kind of things. Okay. So actually phase shift is there. Okay. The phase shift is there. Okay. By using a phase shifting, this can be converted to a plus frequency. Okay. Okay. So mathematically you can have minus frequency value. Okay. But practically, when we are generating signal using oscillators, there is no such signal. Okay. Minus frequency signals. Okay. So you already know that normally signal generators are generating sinusoidal signal. That is a frequency with plus values, no? Okay, not minus value. Okay. So this is a continuous time. Okay, this is a continuous time. And so that means you can have any continuous time value. Okay, so I will go to that MATLAB program again. Okay, so don't worry about this MATLAB program. Okay. Still, if you are not downloading, if you don't have the MATLAB in your computer, don't worry. Okay, I am just using this program. This program we have developed in previous week. Okay, I am just using this program to show you the signal. Okay, otherwise I have to draw the signal by hand, so it is very difficult and it is also not clear. Okay, the writing is not clear. No. Okay. Okay, so it is that is why I use this MATLAB program to show you. Okay, so for example, when you are drawing a continuous time signal, okay, so continuous time signal, actually we no need to use this scatter command. Okay, scatter command, if you use scatter command, I think we have discussed these things. Okay, if you use scatter command, you can see the corresponding y-axis value only, y value. Okay, the calculated point value. Here we define the independent variable. Okay, some independent variable value. Okay, and using this equation, we calculate the corresponding dependent variable value. Okay, when you use scatter, okay, it show corresponding dependent variable value. Okay, and if you plot, if you use this plot command, okay, so it just mark the value, okay, it just mark the value and also join the point. Okay, so it is look like a continuous time signal. Okay, so you can use okay, so it is like this. Okay, so you are getting some t values, so you are marking some t values, some values we don't know. Okay, and using that equation, okay, we are uh, calculating some the corresponding amplitude value like this. Okay, so this is the corresponding amplitude value for 0, this is the corresponding amplitude value for 1, this is the corresponding amplitude value for 2, likewise. Okay, then if you use the scatter command, it will show only this point. Okay, that's all, corresponding uh, dependent variable point. Okay, if you use plot command, it just join these point together. Okay, so plot command you can use to draw continuous time signal, and if you use stem command, it it just mark this corresponding value, and also it show the corresponding x-axis value also like this. Okay, so actually exactly this way we normally represent a discrete time signal, no, graphically. Okay, so graphically if you are represent a discrete time signal, you pointed out the corresponding points, corresponding amplitude points or independent variable dependent variable points, then you show the corresponding time value by joining that value with the corresponding amplitude value. Okay, so this is the exact way to draw the discrete time signal. Okay, so that you can use the stem command for that one. Okay, so stem command will draw this kind of discrete time signal. Okay, so three drawing commands we can figure out. One is scatter, other is plot, other is stem. Plot can be used to draw the continuous time signal. Okay, so now this is the continuous time signal, so I use plot to draw it. Okay, so if I will comment these things. Okay, I will comment. Okay, so you can see that this frequency can be any value. Okay, this frequency can be any value. It can be minus infinity, that means it can be very high minus value, and also it can be go to the plus infinity, that means it can be very high plus value. Okay, for example, it can be, for example, minus 50,000 or something. Okay, so once we okay, once we okay, once we so you can see that now the frequency is very high. Okay, frequency is very high, that means one cycle time is very low. Okay, one cycle time is very low, and this gap is not inside one cycle time. Okay, if you are reducing this gap very much, okay, maybe it will take some time. Okay, yeah, it is not time, it is not, the MATLAB cannot, it will take some time. Okay, because it counting very much point. Okay, now you can see that what I want to show you that. Okay, so you can use these values from any values to any minus value to any plus value. Okay, so it will plot the signal. Okay, it will plot the signal. So maybe these values are not supported by the MATLAB. Okay, so I will reduce this up to some